Dear students, uh, let's start from where we left last time. Uh, Last time we have talked about maximum likelihood decoding, minimum distance decoding. Then we also see the concept of Hamming distance of two words. So what was that? It was something like this: d of x bar comma y bar is equal to number of positions, number of positions at which x bar and y bar differs. Now we are going to see distance of a code. So see distance of a set. Remember the distance between two vectors. Now this is not a distance between two vectors. Okay. So remember the distance is one of the important parameter of a code. One of the important parameter of a code. So I'm just using the word code. Later on in the next chapter, we are going to use a word as linear code. Okay. So fine. So what is this? It's very simple. The notation for distance of a code is d of c. Yeah. How to read it? Distance of a code c. That means capital C is a code under discussion, and we are talking about the distance of that code. So how to define it? So it is just like this. First, we need to find out d of x bar comma y bar such that x bar and y bar coming from C and x bar is different than y bar. So collect such code words. So find it means what? Find out distance between all two distinct code words. See, x bar is different from y bar. Collect all such thing in one set and just take the minimum. Then whatever you will get, that will be called the distance of a code C. Okay. मराठी सांगायला गेलं तर काय करायचं बघा. कोडमधल्या सर्व दोन वेगवेगळ्या कोडवर्ड्समधलं हॅमिंग डिस्टन्स काढायचं, त्याचा मिनिमम घ्यायचा, जे काय येईल त्याला म्हणजे डिस्टन्स ऑफ अ कोड. या सम पीपल ऑल्सो डिफाईन इट लाईक दिस. व्हॉट दे आर सेइंग, distance of a code having at least two code words is the minimum of one set. What is that set? That set contains distance between two distinct distance between all distinct code words. Okay, it is like this. Yeah. So uh, some people also denote it like by just small letter d. That means what is small letter d means what? D of c. What is d of c? D of c means distance of a code. How to define it? We just say it like this. Okay. So it is also one of the important parameter of a code. Don't worry, we are going to see some examples. So example one. Yeah. So see, why am I? So the question may come in your mind: Why this condition is important? Why? What will? Sorry. So what I did, uh, yeah, I should have used highlighter instead of this. Okay, sorry. So what was there? X bar is different than y bar. So what I am saying, why this condition is important? Remember, if this condition is not there, if x bar is not different than y bar, then we know that is if x bar is equal to y bar, then distance will be 0, and each of the time distance of a code minimum of all distances, because we know that distance is satisfies such kind of property. Okay. And we know that if x bar and y bar are same, the distance is equal to 0. If we don't put such kind of property, each of the time distance will be 0, so we will not get anything new. That's why this condition is very very important. Okay, very good. So suppose my code is like this: 0 0 0 1 1 0 1 1. So this is a code over what? This is a code over f2. Yeah. So I will just find it like this: d of 0 0 0 1. Yeah. What is that distance? The distance is 1. How to find it out? Just see this and this. Are they same? No. So now see this and this. Are they same? No. So first 0 0 are same. So uh, it will not be considered into a distance. Now 0 and 1 are different, so it will be 1. Next is what? D of 0 0 1 0. It will be again 1. D of 0 0 and 1 will be 2. Then what is next? D of 0 1 and 1 0. What is that? It will be 2. Then D of 0 1 1, what is again 1, then d of what will be last 1 0 1 1 will be again 1. So collect all such things in one set. So what is that? 1 1 2 2 1 1, and take a minimum. What is the minimum? Minimum is equal to 1. Therefore distance of this code is equal to 1. Okay, so this is the first example. The second example is like this. Suppose my C is like this: triple one, triple two over say f3. Then what is the distance? D of C will be minimum of, now just find out distance between these two. Yeah, so what is that? That is just two fellows. So it is a minimum of just this. Yeah, so minimum of because see all they're differing at each position. So this position is different, then this position is different, and as well as this last position is different. So the distance is equal to 3. Okay, so I hope you understood this thing. So once again, let me just talk you about one remark. The remark is very much important. We are going to use this remark in a number of proofs. So what is this d of c? What is d of c? It is minimum of d of x bar comma y bar, such that x bar comma y bar belong to c and x bar is different than y bar. Yeah, okay. See, minimum of distance is coming out to be d of c. So I will just say that this implies that there exists x bar y bar belong to c, x bar is not equal to y bar, such that such that uh, uh, what should I say, such that um, something happens. Yeah, so what is happening, such that d of c is equal to d of x bar comma y bar. So I can just say like this, or yeah, it's like this. सो इन मराठी लेट मी जस्ट टेल यू, म्हणजे काय बघा, अशा सर्व प्रकारच्या मिनिममचा मिनिमम जो येतो तो डी ऑफ सी येतो. म्हणजेच काय, डी ऑफ सी ही व्हॅल्यू मॅच होणारा डी ऑफ एक्स बार कॉमा वाय बार प्रकारचं डिस्टन्स त्या ठिकाणी असणार. सो दॅट दॅट वॉट आय 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 वॉन्ट टू दॅट वॉट आय वॉन्ट टू से. ओके, सो फाईन, दिस इज द this is the remark number 1 that I would like to tell you. So I will talk about another remark in a couple of minutes. But before that, let me just tell you one new definition. The definition of what I mean by NMD code. So I hope everybody knows what I mean by NM code. What I mean by NM code: code having length n and code having size n. So what I mean by NMD code: a code of length n, a code of uh, length n, size m, and distance d is called as NMD code. Yeah, and remember this n, m, d. So this what I want to say, I want to say something like this. In MD, these three numbers are called as parameters of code. Parameters of code C. Okay, so let's see some example. Example number 1. So we know that C was 0 0 0 1 1 0 1 1, and we just find out what is distance between these two. Distance between these two is 1. Distance between these two is how much? It is again 1. Distance between these two is 2. Distance between these two is 2. Distance between this one and this one is 1, and lastly distance between this and this is 1. So what is minimum? This minimum distance is 1, so d is equal to 1. So therefore this code is 2 comma 4 comma 1 code. So 2 is the length. You can just see that 2 is the length of each of the code word from here, 4 is the size of this code, and 1 is the distance of this code. Okay, so very good. uh, and since this is a code over EF2, some people also say that C is binary 241 code. Okay, or some people say C is 241 binary code. So whatever uh, is whatever the way you are comfortable uh, is okay. So now question you make on your mind, oh, how to learn the concept of uh, distance of a code. Why to learn the concept of distance of a code? Yeah, so the answer is very simple. uh, Answer is this: by this concept we can we can interrelate the concept of error detection error detection and error correction. So we are going to define two things about error detection in the uh, during the transmission of a code via noise channel, and error correction. And during that things, this distance will be an important role. That's why we are going to see this thing now. The only two things are remaining from the chapter, and they are uh, indeed very very important. There are two big theorem, perhaps the biggest theorem in the whole of this course. uh, but before that, let me just define one thing. What is that called as u error detecting code? U error. So we are going to see what I mean by error detecting code. We are going to see that what I mean by error correcting code. But in order to correct error, first there should be errors, and they should be detectable. Because if you are not able to detect the errors, then there is no chance of correcting the error. So that's why we are going to see the concept of what I mean by U error detecting code. This is very very important concept. Okay, so very good. So let's see what is this. Let U be a natural number, or you may say positive integer. Let U be a natural number, or you may say U be a positive integer. A code C is U error detecting if whenever a code word incurs means uh, in Marathi we can just say ओढवून घेणे. Okay, so or commit. Yeah, a code sees you detecting if whenever code word incurs, what it incurs, at least one, but at most you errors, then resulting word is not a code word. Yeah, resulting word is not a code word. So it's a little bit uh, uh, involved sort of definition. What is this? See, we want to detect the error, so there should be some errors. So we are forcing to make the error. So what it says, a code C is you error detecting if whenever code word incurs at least one, but at the most u errors. म्हणजे काय बघा, जेव्हा ट्रान्समिशन होत आहे कम्युनिकेशन चॅनलच्या अक्रॉस, तेव्हा काय कुठल्याही कोडवर्डला कमीत कमी एक आणि जास्तीत जास्त यू एरर्स होऊन देण्याची मुभा असेल. ओके, सो अ कोडवर्ड incurs, or if code word is allowed to commit at least one, but at the most how many errors? U errors. Then whenever we used to we allow that any code word to have at least one but at the most U errors, then what a resultant thing after the transmission should not be a code word. कळतंय? म्हणजे काय करायचंय बघा, ट्रान्समिशन आपण जेव्हा करतोय कम्युनिकेशनच्या अक्रॉस, त्यावेळेस काय झालं पाहिजे, कुठलाही कोडवर्ड जर तुम्ही घेतला, कोडवर्ड मीन्स अ पार्ट ऑफ सी, ओके, तर कमीत कमी एक आणि जास्तीत जास्त यू एरर्स करायला तुम्हाला अलाउड आहे. हे केल्यावर मिळणारा जो काही वर्ड आहे, मिळणारा जो काही कॉम्पोनंट आहे, मिळणारा जो काही व्हेक्टर आहे, तो कोडवर्ड असता कामा नये. Okay, that I mean by U error detecting code. Okay, so one more definition, don't worry, we will see plenty of examples, because see, the definition will not be clear unless and until we take a definition. Okay, so definition of what I mean by exactly U error, U error detecting code. Example, definition of this, is the definition is very simple. What it says, uh, uh, a code which is U error detecting but not U plus one error detecting. Such a kind of code is called as exactly U error detecting code. ओके, जो कोड यू एरर डिटेक्टिंग असेल परंतु यू प्लस वन एरर डिटेक्टिंग कोड नसेल, त्या कोडला म्हणायचं एक्झॅक्टली यू एरर डिटेक्टिंग कोड. डोंट वरी, वी आर गोइंग टू सी एक्झाम्पल्स ऑफ बोथ ऑफ these things. So I hope you understood what we have seen. So example number one, suppose my code is like this. So what is this? See, 1 2 3 4 5. So this is 00 111 and 1 2 3 4 5. So can you just tell me what are the parameters of this code? So this is, see, length is 5, length is 5, size is 3. What is distance? See, you can just see distance between these first two fellows is how much? 3. Okay, the distance between first and last is 5. Distance between this and this is what? 2. Okay, so minimum distance is what? Minimum of this string is 2. So this is 532. This is a code or what, which alphabet? F2. So is 532, I should say, binary code. Okay, so this is the code. So maybe I will just call it as, let's say, C1. Okay, so now see, we want to see a we want to clarify the definition of what I mean by sorry, what I mean by error detecting code. So we want to forcefully make errors, and we need to take care of all code words into the consideration while doing it. Okay, see, तर काय करायचंय बघा, प्रत्येक कोड वर्ड घ्यायचा, त्याच्यामध्ये कमीत कमी एक आणि जास्तीत जास्त यू एरर्स. आता यू काय तो आपल्याला फाइंड करायचा आहे. सो लेट्स टेक इट 1 2 3 4 5. आता so what is the code alphabet? Code alphabet is F2. That means my symbols are only 0 and 1. That means if you want to change 0, 0 can be changed to 1, and if you want to change 1, 1 can be changed to 0. Okay, so see, uh, आता मला so what I want to change the bits. So remember, this first place is 1 bit, second place is 1 bit, third place is 1 bit, fourth place is 1 bit, fifth place. So याला bit position ला 1 bit म्हणूया. Okay, so yeah, so if I change any one position, if I change any one position, if I change the first position, what will I get? I'll get like this. Yeah, then this is not a part of this set. Am I right or not? So this is good, because what we want to make errors, so that errors can be detected. So what it says, a code C is error detecting if whenever code word incurs, स्वतःहून आपल्याला त्यामध्ये एरर करायचे आहेत. ओके, त्यात किती एरर करायला अलाउड आहे? कमीत कमी एक आणि जास्तीत जास्त यू आपल्याला फाइंड आउट करायचा आहे. ओके, तर एरर करताना काय झालं पाहिजे, जो काय मिळणारा वर्ड आहे, मिळणारा मेंबर आहे, तो मेंबर हा सीचा असता कामा नये. ओके, सो व्हेरी गुड. So first thing, if I change any one position, see, if I change the second position from this code word, what will I get? 0 1 000. Again 0 111 0 1 000 is not a part of C. You can just see that means just error, doing one error means what? Doing one error means what? Changing any bit to 1. instead of 0 should be 1. If I do it each of the time, first पहिला बीट चेंज केला मला हा मिळेल, दुसरा बीट चेंज केला मला काय मिळणार, याच्यामध्ये हा मिळणार, तिसरा बीट चेंज केला मला काय मिळेल, 0 0 1 0 0. ओके, नेक्स्ट बीट चेंज केला मला काय मिळेल, 0 0 0 1 0. नेक्स्ट बीट चेंज केला मला काय मिळेल, now and you can just see that none of this is a part of C, none of this is a part of C, so it's good. So for one error, no issue. Okay, so now let's take 0 0 1 1 1. Now change any one bit, change any one bit, change any one bit. So let's start from first there means if I change the first bit, what will I get? I'll just get 1 0 1 1 1. Again, this is not a part of C, but while doing the changes we should be clever enough. See, now see, we want to stop at which place where we are not able to detect the error. एरर डिटेक्ट झाली पाहिजे म्हणजे काय झालं पाहिजे, आपण बीट चेंज केल्यानंतर तो जो काही फेलो मिळतो आहे तो या सेटमध्ये गेला पाहिजे. आता बघा, याला जर मला बीट चेंज करून मला या सेटमध्ये येऊन द्यायचं असेल, सो देन आय विल नॉट डिस्टर्ब दिस लास्ट 3, आय जस्ट डिस्टर्ब दिस first two. Okay, but see, we are here at the first place, we are just doing one error. So if I do the one error at the first place, I will just get this thing. If I do the change in the second bit, I will get such kind of thing, 0 1 1 1 1. So again, they are not a part. Even though we change the third one, you will get 0 0 0 1 1. Again, this is not a part of C. If I change next one, again that is not a part of C, and so on. So this is again not a part of C. The similar thing, if you take the third word, change any position. So change any bit. If we change any bit, whatever object we will get, that is not a part of C. So if I do if you do if you change, if you commit, or if you allow to do one error, then there is no issue. So whatever we are doing, whatever we have done, we have allowed to do one error. Okay, we are allowed to do one error. Now what I want to do, uh, now so see, what shall I yeah, so let me just do it like this, so that I will be able to see. Okay, fine. Now next I will allow to do two errors. Okay, so what is my first fellow? It is what? So I'm allowed to do two errors. What is my next fellow? It is what? 0 0 1 1 1. What is my next fellow? 1 1 1 1 1. Yeah. If I do, if I change any two positions, I cannot go into the set once again, because what is my set? My set is like this: 0 0 0 0 0, then 0 0 1 1 1, and last is 1 1 1 1 1. Okay, so this कोणती पण दोन पोझिशन चेंज करा बघा याच्यामध्ये, तुम्ही या सेटमध्ये येत नाहीये. सो अगेन it works. Again, it works means what? If I allowed to do two errors, whatever I will get, that is not a part of C, and that's what I want. Okay, it works. But see, if you do two errors, see, while doing a two errors, we need to take care of each positions. Yeah, if you say that I will just change these last two positions, okay, that is not a part of C. 0 0 1 0 0, that is not a part of C, but we need to take care of each bit position. So you can just see that now if you do the two bit changes, if you do the bit changes at the first two places, what will you get? You will get 1 1 1 1 1, but that is a part of C. Since it is a part of C, we will not able to detect the errors. Yeah, yes or no? So at for two positions, for two bit changes, for two bit changes here, the process fails. The process fails. So we need to stop over here. We need to stop over here. Why? Because see, if we allowed to do two bit changes at the first two positions, we are whatever we are getting the value as 1 1 1 1 1. That means 5 times 1, and that is a part of C. So so you will not able to detect the errors. So forget about the next one. पुढे जायची पण गरज नाही बघा. आपलं काय म्हणलंय? So that's why the definition is very nice. It says if whenever जेव्हा केव्हा या कुठला जेव्हा केव्हा कुठल्याही कोडमध्ये कमीत कमी एक आणि जास्तीत जास्त यू एरर जर आपण केल्या तर जो मिळणारा जो काही ऑब्जेक्ट असेल तो सीचा पार्ट असता कामा नाही. त्यामुळे ह्या ठिकाणी आपला एक्सपेरिमेंट फेल झाला बघा. पुढे जायची पण गरज नाही. ठीक आहे. Or you can just say that okay, if you want to go towards that, because see, we don't need to go at there. Experiment must fail at any instance. Okay, so here if you say that I will just 2-bit changes, then if you say that I will just do 2-bit changes at the last two position, it will not work. But if you say that you change the 2-bit position at first two places, then you will get 0 0 1 1 1. Again it is a part of C. So again whatever experiment, that experiment fails. Okay, so that means you are allowed to do how many errors? Just you are allowed, therefore uh, therefore committing at least one, because see, we have written over here somewhere we are allowed to do 1 year. And see why I'm using at least, because in a definition what they're saying, if कोड incurs at least one, कमीत कमी एक आणि जास्तीत जास्त यू एरर करायला अलाउड आहे. आता इथे बघा कमीत कमी एक आणि जास्तीत जास्त किती एरर करायला अलाउड आहे बघा, सांगा बरं. एकच. कारण बघा, for 2-bit changes the process fails. So that's what I'm saying. See what is going to happen here. Committing at least one, and at the most one error is, so this whenever there's at the most I should use u, because in the definition what they're saying that uh, at least one but at the most u errors. Okay, so what is the value of, so number of errors which we are committing are at least one, at the most one. Therefore this code, so I think we have called it to be C1, but somewhere I have missed. So yeah, it is C1. So I should use C1 C1 C1. So it is also C1 C1, or I should write it neatly. C1, and this is again C1. Therefore this code C1 is one error detecting code. Okay, and see this code is not detect, and this code is one error detecting code, but not two error, but not two error detecting code. Yeah, so we have seen it over here that if we commit two errors, if we allow to do two errors, so I should say here something like allow instead of saying allowed. Yeah, I should say allow, or I should say more correctly something like this: if allowed, to do two errors. Okay, yeah, okay, so fine, this code is one error detecting but not two error detecting. So that's why this will be this. See what is the definition of exactly you are detecting code? Something which is you are detecting but not u plus one error detecting. So this C1 is an example of code. Therefore I should say this is equivalent to C1 is, what is the word? Exactly, C1 is exactly one error detecting code. Okay, C1 is exactly one error detecting code. Because why? Exactly, whenever the word exactly is coming, so what is the meaning of exactly? You are detecting code, it means what? It's allowed to do so it is u error detecting but not u plus one error detecting. That is the meaning of exactly u error detecting code. Okay, so let's see another example. Another example is something like this. Suppose I'm taking C2. So this is like 1 2 3 4 5 6. Okay, 1 2 3 4 5 6. So there are 6-bit position, that's why I'm counting like this. And last is what? This triple one triple two. Okay, So do the same sort of experiment. Suppose I will do so I need to so first thing, if allowed to do one error. So this is a code over, remember, code symbols are 0, 1 and 2. So this is a ternary code. So this is which kind of code. So if you want to write down a parameter, so 6, what is size? Size is 3. What is the distance? What is the distance? Distance is, you can just see it is again 633 code. It is a 633 code. Okay, because see, if you find out distance between this and this, what is the distance between this and this? This is what? 3. The distance between this and this, it is 6. The distance between this and this, that is what? Again 6. What is the minimum of 3, 6 and 6? Minimum is 3. That's for the 633 code. If you have to do one error, so see, now if you change any one bit from here, you cannot land up in that set once again. बघा, कुठे इथं पहिला 0 1 करा, तुम्हाला हा सेकंड किंवा थर्ड मिळू शकत नाही. कुठलीही पोझिशन चेंज करा, 0चं 1 करा किंवा आता बघा बीट चेंजेस करायचे म्हणजे आता दोन थिंग अलाउड आहे बघा. 0ला चेंज करायचं म्हणजे 0ला दोन चॉईसेस आहेत, एक तर 1 करू शकता किंवा 2 करू शकता. कोणतंही करा, तुम्ही आज जाऊ शकत नाही. सो फॉर दिट नो इश्यू. 4 5 6 no problem. Yeah. uh, if you take this 000 111, if you do one error, then again no problem, you can just see that. Yeah, if you change any bit, suppose you just change last bit, let's say 120, you will go reached, you will go nearer to this, but you will not, you cannot achieve this. Yeah. Similarly, if you change if you take this and if you do one error, then again there will be no problem. Okay. So if we so if you do this, then there is no issue. So next, if allowed to do two errors, then what with that? So let's see. I will do it like this. So 000 000 first thing. So suppose I will do two errors at any position, but I will not concentrate on these first two places. Why? Because see, while doing a error, I should keep it in mind that uh, I should refrain myself to go inside the set. एरर मला जेव्हा बीट पोझिशनला चेंज करायचं असेल तेव्हा मला त्या सेटमध्ये जायचं नाही. ज्या सेटमध्ये जाईल ना मी, सेटमध्ये जायचं नाही, पण परंतु सेटच्या जवळ जाण्याचा प्रयत्न करायचा आहे. ठीक आहे. का? कारण जेव्हा एरर आपण जेव्हा आपण त्या कोडमधला आपला मेंबर मिळेल त्यावेळेस आपल्याला थांबायचं आहे. त्यामुळे मी so we should be very much clever while doing the bit changes. See, I will not try to change these bits, first two bits. Why? Because even though I do it, I will be outside the set, but still I will not be near to set. But I should be careful enough. I should try to do the changes in last two bit positions. Why? Because if I do the changes in last two bit positions, then I will be in a position to go nearer and nearer to the set. Because so if I do the last two bit changes, what will I get? 000 011. Then I will go a little bit toward this second code word. Yeah, so we should be mature enough or clever enough to do the bit changes. But still, if I do it, this is not a part of C2, but still it will be nearer to C2. Okay. So the next 000 111 म्हणजे बीट चेंजेस करताना, while doing a beat changes, तुम्हाला काळजीपूर्वक बीट चेंजेस करायचे. बीट चेंजेस करताना एरर झाली तर पाहिजे, परंतु मिळणारा जो काही ऑब्जेक्ट आहे तो त्या कोड मधल्या कोडवर्डच्या जवळ गेला पाहिजे. जवळ गेला पाहिजे, मग त्याच्याप्रमाणे दिसण्याचा, त्याच्याप्रमाणे येण्याचा त्याचा प्रयत्न असला पाहिजे. ठीक आहे. सो नाउ while doing it, suppose I want to commit two errors, so I will not change, I will not affect the initial code, initial bits. Why? Because if I affect the initial bits, I will be outside the code C2, but still I'm I will not be nearer. Okay, so I hope you are getting the meaning of nearer. But I will try to change these two bits, or I will try to change these last two bits. Why? Because if I do so, I will be nearer to this fellow. Okay, so again, if I do so, I will not the part of C2. Again, if I take triple one, triple two, and if I do 2-bit error at anywhere, again I will not a part of C2. Okay, so I hope you got it. So now that means here the value of u is 1. Now here the value of u, at least value of u is 1. Okay, so what is next? If allowed to do 3 errors. Okay, so now see. So first thing is triple zero, triple zero. Suppose I will allowed to do 3 error. Okay, so see, I told you that you should be clever enough to do the you should be clever enough to do the errors. Okay, so okay, yeah. So fine. What is your C2? Yeah, it is like this. Now this is your C2, and you are allowed to do 3 errors. The baga. So what will I do? Let me just write down your C2 once again. C2 is then what is next? Triple zero, triple one, and triple one, triple two. This is your C2. Okay. If I want to do 3 errors, you can just see that I told you that commit or change the bit position in such a way that object should be outside the set, but should be nearer and nearer to the objects in the set. Okay, objects in the code. If I do the last 3-bit changes, so what will I get? Triple zero, triple one, and this is a part of C2. Therefore, experiment fails. So I told you that you are allowed to do any bit changes by whatever available code symbols. Yeah. Yes. So here if I do any आता तुम्ही म्हणताल मी समजा सुरुवातीच्या 3 बीट चेंजेस करेल, ठीक आहे, तुम्हाला काय मिळेल ऑब्जेक्ट? You will get triple one, triple zero. Again, this is not a part of pseudo, but while doing the bit changes, we should take care of each bit position. म्हणजे कुठली डेफिनेशन काय सांगते? तुम्ही कुठलेही बीट पोझिशन चेंज केला तर मिळणारा ऑब्जेक्ट हा त्या सेटमधला नसायला पाहिजे, परंतु या ठिकाणी लास्टचे 3 बीट जर मी चेंज केले तर मिळणारा ऑब्जेक्ट हा सेटमध्ये येतो, म्हणजे एक्सपेरिमेंट काय होतो? फेल होतो. म्हणजे यूची किंमत कमीत कमी किती झाली? कमीत कमी 1 तर आहे आणि जास्तीत जास्त किती आहे? 2 आहे. कारण 3 केल्यावर काय होतं? एक्सपेरिमेंट काय होतोय? फेल होतोय. ओके, therefore and since experiment fails at very first instance, we don't need to take care of this last two. Okay, therefore C2 is 2 error detecting code. Therefore C2 is 2 error detecting code, and therefore C2 is exactly 2 error detecting code. Why exactly means what? Whenever exactly, that means it is 2 error detecting but not 3 error detecting. Yeah, so it is not, if we allow to do 3 errors, then experiment fails. Okay, so very good, I hope you understood it. So remember, if you have a solid foundation of this definition, an example of u error detecting code, then and then you will able to understand the concept of what I mean by next or forthcoming definition of error correcting code. Okay, so let's see one important theorem as far as this u editing code. It is like this. uh, Code C is u error u error detecting code if and only d of c. What I mean by d of c? It is a minimum distance of a code if and only d of c greater than equal to u plus 1. Okay, see, I will let you know what I mean by this. I told you that generally we used to write down d of c as d. So here we have seen somewhere that we used to write down, yeah, d of c as d. Okay, this it is a convention. Okay, so fine. So that is uh, I will just say a code C is u error uh, detecting code if and only if d is greater than u plus 1. So from here what will I get? I will get the value of u as what? Value of u is less than equal to d minus 1, but I know that the minimum value of u is what? At least 1. Okay, so I will just formulate in another word. See, what is the at least value of 1? At least value of u is what? 1. At the most value is what? D minus 1. That means I'm not allowed to, I'm allowed to just do how many bit changes? At least 1, and at the most D minus 1. It says that that means if I do the D bit changes, experiment fails. That means this code has to be D minus 1 error detecting code, but not D error detecting code. That means that is a code with distance D is an exactly D minus 1 error detecting code. Why exactly? Exactly means what? It is D minus 1 error detecting code, but not D error detecting code, because the value of u is at least 1 and at the most u minus 1. So now the question may come your mind: why am I am I so much interested in this theorem? The Because the thing is this, this theorem allows you to find out error detecting capacity of given code in faster way. In faster way. So what I mean by faster way, see, in example 1 and example 2, we were finding out error detecting capacity, but for that purpose we need to take care of each of the code word. Then we are performing beat changes, but while doing this it consumes a lot of time. So we don't want to become lazy, but we want to do more efficient. And for doing so, we are seeing this theorem. And see, you can see that in this theorem, who is playing the important role? Distance is playing the important role. That's why earlier I said somewhere, so maybe, yeah. So here I written why to learn the concept of distance of a code. So answer I told you here. What is the answer? By this concept, we can interrelate the concept of error detection and error correction with that of diopsy. What is diopsy? Diopsy means what? D. Okay. So we'll take this theorem and then we'll stop. So proof proof is also very much simple, a little bit um, bit small. Okay. So fine. So this if and only, there are two parts. Okay. Yeah. So what is if and only part? So what we want to uh, do like this. So I will just first prove this part. This part means, so I will just prove this. So what I am going to assume, let d of c greater than equal to u plus 1. Let d of c greater than equal to u plus, that is d greater than equal to u plus 1. Yeah, because d of c is usually denoted by d. So what is my claim? My claim should be what? The code should be u error detecting code. Yeah. Okay. So what is my claim? Claim is c is u error detecting code. Okay, this is my claim. Yeah, so fine. So so let me see something. If c bar belong to c and x bar are such that 1 less equal d of c bar is a code word, and we haven't said about x bar. Yeah, x bar may be a part of c or x bar may not be a part of c, but since we have written just x bar right now, the whether to call x bar as a code word or word, it's not yet clear. Yeah. So if it is like this, u, and you know that u less than d of c. Yeah. So why this is coming? You can just see that this step, because see, u less than d of c means what? D. U less than d, that means what? U will be less equal what? D minus 1. That means value of u is at least 1 and at the most d minus 1. So what is the meaning of this? See, what is the meaning of d of c bar comma x bar? It means number of positions at which c bar and x bar differs. So here one less equal d of c bar comma x bar means what? C bar and x bar differs at least one position. Okay, because we learn the definition of what I mean by d of c bar comma x bar, and it is less than equal to u. It less than equal to, and u is less than equal to what? D minus 1. Yeah. Okay. So so what I'm saying is like this. Okay. Yeah, so fine. So we are taken the c bar as a member of C, and x bar is just such kind of thing. So what it says that uh, if uh, if if c bar is allowed to commit at least one bit change, because see this thing, and at the most how much? U. At the most u bit changes, then resulting resulting fellow, that is x bar, resulting, what is the resultant fellow? X bar is not a part of C. Okay, that's what we want. Yeah. Therefore, therefore C is how much error detecting? See, we are allowed to do how many? At least one bit change, and at the most u bit, that is कमीत कमी एक error एक बीट चेंज करायला अलाउड आहे, जसं यू बीट चेंज करायला अलाउड आहे. तर ते केल्यानंतर मिळणारं जे काही आहे, मिळणारा जो काही रिझल्टंट वर्ड आहे, दॅट इज नॉट अ पार्ट ऑफ सी. देअर फोर सी इज यू एरर detecting code. U error detecting code. But still it is not clear why. So why, what is not clear? Why x bar is not a part of C? See, you can just see that what is minimum distance? Minimum distance is what? At least u plus 1. म्हणजे कमीत कमी distance दोन. See, what, who is playing important role? D of C. What is D of C? Minimum of D of x bar comma y bar, such that x bar comma y bar belong to C and x bar is different from y bar. And this, what is this minimum? Minimum is D of C, but D of C means D, that is at least u plus 1. म्हणजे कुठल्याही दोन कोडवर, कोणत्याही दोन वेगवेगळ्या कोडवर मधलं अंतर हे कमीत कमी u प्लस 1 आहे. हे कमीत कमी u प्लस 1 आहे. मी कोडवर्ड शब्द वापरतो. कोडवर्ड म्हणजे सीचं पार्ट, सीचे मेंबर. पण बघा ह्या ठिकाणी काय होते, सी बार आणि एक्स बार मधलं कमीत कमी डिस्टन्स 1 आहे आणि जास्तीत जास्त यू आहे. आता मिनिमम डिस्टन्स कमीत कमी किती आहे? यू प्लस 1. म्हणजे आणि ह्या डिस्टन्स पेक्षाही कमी डिस्टन्स मला या ठिकाणी मिळते, कारण यू प्लस 1 पेक्षा यू हा नंबर छोटा आहे. सो नक्कीच, आणि सी बार हा कशातला आहे? सी मधला आहे, आणि एक्स बार बद्दल मला माहित नाही. आणि आपलं म्हणणं काय बघा, कमीत कमी डिस्टन्स काय आहे? यू प्लस 1 एवढा आहे. म्हणजे आणि कमीत कमी डिस्टन्स, so minimum distance of a code means what? We used to find out a distance between any two distinct code words from code C, and then we used to take a minimum. Yeah, remember x bar and y bar, both are members of C. X bar and y bar both are members of C. Yeah, then and then this is happening. But now here we are getting two fellows, C bar and X bar. Out of that, one fellow is guaranteed to be a member of C. Yeah, and but distance between them is what? U. But minimum distance is at least u plus 1. It means necessarily X bar has to be a fellow outside set C. That's why we are getting it like this. That means if you take a C bar, and if you are to do at least one changes and at the most u changes, then the resulting fellow is not a part of C. Therefore, this C is u error detecting code. Remember that. So now this becomes clear. So who is playing the important role? Distance is playing the important role. Now, uh, so again, if you are not getting it, then we are going to take a doubt clearing session. In that, this will become clear one more times. Okay. So now, what I need to assume, so I will assume that let C be U error detecting code. Let C be your detecting code. What should be your claim? Claim is like this. What is your claim? d of c greater than equal to what? U plus 1. D of c means actually d. And what do you mean by d of c? Find out distance between any two distinct code words. Distinct means x bar different from y bar, and x bar and y bar should belong to c. Take its minimum. Whatever you will get, that will be d of capital C, and d of c means what? Small d. Okay, so that I mean by uh, this minimum distance. Okay, fine. So my claim is like this. I will go by contradiction. I will go by contradiction. That means I assume that this should be wrong. So I'll just say that let d of capital C is strictly less than u plus 1. Yeah, is strictly less than u plus 1 means what? That is d of capital C is less equal u. Yeah, so that is minimum distance of a code is less equal u. Correct? Minimum distance of a code is less equal u. But what I mean by minimum distance, it means distance between two distinct code words. Distance between any two. So just first find out distance between any two uh, say x bar different from y bar, that means distinct, and x bar y bar belong to c means code words. Find out distance between any two distinct code words, take its minimum, that will be called as d of c. Okay, so that minimum distance is less equal u. Okay, so what I mean by this implies there exists c1 bar comma c2 bar belong to c, such that what is happening, such that 1 less equal d of c1 bar comma c2 bar, it will be d of c. So see, the same thing I talked earlier, so I hope you remember, like this. Yeah, this remark number 1 is very important. Baga, where is remark number 1? Yeah, it gone. So d of c is equal to minimum of d of x. बघा मिनिमम कोणाचा काढतो? डिस्टन्सच काढतोय. त्यामुळे मिनिमम, आणि तो मिनिमम जो काही नंबर आहे ना तो d ऑफ c होणार आहे. म्हणजेच काय, त्या ठिकाणी असे दोन कोड्स असणार x बार कॉमा y बार c मध्ये, आणि ते दोन वेगळे असणार. आणि what will happen because of that, d of c will be equal to d of x bar comma y bar. So therefore by remark number 1, therefore, so, or this is coming because of remark number 1. Yeah, uh, why this is so? By remark 1 above, by remark 1 above. Okay, and we know that d of c less equal u, we know that d of c less equal u. So what we are doing, therefore 1 less equal d of c1 bar c2 bar less equal to u. So now what I mean by this first thing, what I mean by what I mean by this first, and what I mean by this second. Okay, so see what I'm saying, I'm saying something like this. Okay, 1 less equal d of c1 bar comma c2 bar means what? C1 bar and c2 bar differs from each other at least one position, and d of c1 bar comma c2 bar less equal u means what? C1 bar and c2 bar differs from each other at the most u position. See, I'm using the word at least and at the most. So a ring should or bell should run, bell should ring in your mind. तुमच्या आपण मनात एक ट्यूब पेटली पाहिजे बघा, काय आपण ऍटलिस्ट आणि ऍट द मोस्ट शब्द वापरतोय. ओके, सो नाउ यू कॅन जस्ट सी दॅट C1 bar and C2 bar both are the members of C, and we are allowed to do at least one bit changes, and we are allowed to do at the most u bit changes. Okay, okay, therefore it is just like start from C1 bar, do at least one error, you will again that means you are allowed to do one error, and if you do at the most u errors, you will again a part of C, because see, C1 bar and C2 bar are the parts of C. Therefore I'll just say experiment fails. कळतंय? C1 bar and C2 आपलं काय बघा, कमीत कमी एक बीट चेंज आणि जास्त जास्त यू बीट चेंजेस जर केले तर मिळणारी जी काही गोष्ट आहे ती सेटच्या बाहेर गेली पाहिजे, पण सेटच्या मध्ये आहे. ओके, the experiment fails, and this is fails because of the thing, we are going by contradiction. Okay, so this is a contradiction, therefore we must have d of c greater than equal to what? U plus 1. Okay, so fine, this is the end of the proof, this is the end of the proof. So now let's see the usefulness of this because see, I written somewhere over here. I written somewhere over here. This theorem allows me to find out error detection capacity faster. So I'll just take the example of C2. So I'll just say uh, apply this theorem to C2. What was C2? It is 456. Then what? Triple zero, triple one, then triple one, triple two. So we want to find out the it is how much error detecting. So what? Just find out the distance. What is the minimum distance of this C2? So we found out. So distance between this and this is how much? It is what? 3. Distance between this and this is how much? It is what? 6. Distance between this and this is how much? It is again 6. So minimum distance is what? 3. So what is the theorem says? C is U error detecting if and only for d of c greater than equal to what? U plus 1. What is d of c here? What is d of c? 3. So 3 greater than equal to u plus 1. It is possible if and only if what? U is at the most 2. So therefore u is at least 1, u is at the most 2. Therefore this code is what? 2 error detecting code. Okay, so fine, that's why this theorem is useful. We don't need to find out, we don't need to commit the bit changes and so on and so on. So the next part is something called as v error correcting code. So till this place, till this moment we have talked about error detection. Now after error detection, what is there? Error correction. So that will be seen in a next lecture. Okay, so fine, I will just